6 for year 13 physics on SHM equations. You will see there is no lesson 5 because I used that time to solve problems on the reference circle. So this one's on SHM equations for timing starting at the equilibrium position. So the reference circle allows us to solve problems involving displacement, velocity and acceleration of the SHM particle. What we need to keep in mind is remember the radius of the reference circle is the amplitude of SHM. The constant speed of the reference particle is a omega, and that's your maximum speed of the SHM particle. And the constant acceleration of the reference particle is a omega squared, which is the value for maximum acceleration of the SHM particle. At all times, the displacement, the velocity, and acceleration of the SHM particle is the vertical component of the displacement, velocity, and acceleration of the reference particle. So we'd already done the equation for displacement of the SHM particle. So the displacement at any instant of time generates a sine curve, and it is equal to y equals a sine theta, where a is the amplitude and theta is the angle through which the reference particle has moved in that time. And because theta is omega t, this can also be written as y equals a sine omega t. Velocity is a maximum at equilibrium, so using the reference circle, we can come up with the equation. The velocity at any instant of time is the cos of the maximum velocity. So it's a omega cos theta or a omega cos omega t, where omega equals 2 pi f, or omega is 2 pi over t. Now the velocity of the reference particle is always a tangent to the circle, and it has a constant value of a omega. Looking at acceleration, acceleration is always directed towards the center of the circle, so acceleration phasor points 180 degrees opposite the displacement phasor. So at the start, the acceleration phasor is here, the displacement phasor is here. So going through a time t, you get that angle, and the value for maximum acceleration is a omega squared, and this is your acceleration phasor, acceleration of the SHM particle when it has moved a distance, and so you end up with a negative sine curve, which is a negative a omega squared sine theta, or negative a omega squared sine omega t. And when solving problems, if you're using theta, then your calculator needs to be in degrees. But if you're using omega t, then your calculator needs to be in radians. And the reason is omega is measured as radians per second.